Hi guys, let me bring you to the introduction of relativity. What exactly is relativity? Relativity is a theory developed by Albert Einstein in 1905. He explains how space, time, and motion behave at very high speed and replace several limitations of classical Newtonian physics based on the behavior of light and motion. And the interesting fact is, before Einstein, many scientists believed that time was universal and identical for everyone. Why do we need to know about relativity? Well, this topic we chosen because it's conceptually fascinating for us and it connects mathematics with real-world physics, an essential foundation for modern physics, and last but not least, it's used in technologies we depend on daily. And such modern applications we're talking about is GPS satellites, nuclear energy, particle accelerators, and astrophysics and black holes. The firm foundation for special relativity, we have two postulates here. Einstein two postulates here. The first postulate is the laws of physics are the same in all inertial frames. While for the second postulate, it's talking about the speed of light in vacuum is constant for all observers, and the consequences, space and time are not absolute actually, and the observer can measure different time and length, which leads to the concept of space-time. In space-time, we relatively combine the three dimensions of space and only one dimension of time. Together they form a four-dimensional structure called space-time. And why is it matters? Because events like this can appear different depending on the observer's motion. For example, two observers moving differently may dis- disagree on the time interval, distance, and simultaneous events.
First, we would like to introduce the time dilation formula, which is defined as the moving clocks ran slower compared to stationary clocks. The equation as shown or stated below is delta t, which is equal to change in time, equals to delta t o, which is the t first, t node, over 1 over square root 1 minus v squared over c squared, v for velocity and c for the speed of light. Now, also included below the formula or equations is that as velocity approaches the speed of light, time passes more slowly and thus the effect becomes stronger. Take, for example, in the movie Interstellar, there's a scene where this one team were landed on this one particular planet, which is whose orbit is actually closer to the black hole, which slows down the time there. And now back on Earth, decades has passed, 10, 20 years has passed, whereas for the team on that one particular planet, only 4 years has passed.
All right, for the twin paradox in scenario, for example, we have one twin remains on Earth, while the other twins travel at relativistic speed in space. In result, we have the traveling twins age more slowly. So what the twin paradox demonstrate is time is relative, motion affects its aging, and time is not universal.
Next, we take a look at the length contraction formula, which states that objects moving near the speed of light appear contracted in the direction of the motion. And as shown on the formula below, or the equation below, L equals to L naught square root V squared over C squared, which appears to be identical to the formula shown earlier, which is the time dilation formula. Now, this formula basically whole point is to say that objects becomes shorter at high speed. Next, we take a look at the most important equations introduced in the early 20th century by none other than Albert Einstein. His famous equations, which is E equals to mc squared, is actually mass of a substance multiplied by the square of the speed of light. Now, the meaning behind this equation is that mass can indeed be converted into energy, and that even small amount of mass may contain an enormous amount of energy. Take astrophage, for examples, or even gamma ray, for examples. Now, the applications for these equations or formula is for nuclear for power plants, and then atomic bombs, and then lastly, the stellar energy from the sun.
Okay, for the relativity in real life, we have three, which is the GPS navigation. So GPS navigation works through satellites clocks experience relativistic effects. So without corrections, the GPS will encounter error rapidly, and the other which is the navigation system would fail. For the second, we have the particle accelerators, which used to predict the behavior of particles moving near the light of speed. So the last one, we have the nuclear technology, which relies on mass energy conversions. Okay, for the next one, we have the muon-Decay experiments. So what are muons? Muons are unstable subatomic particles and is also created in Earth upper atmospheres. So by undergo the muon-Decay experiment, the expected outcome we have the muons should decay before reaching the Earth. And the actual observation, which is they survive longer because the time dilations slows their decay. So why does this experiment matters? Because it provides strong experimental evidence for relativity.
Next, recent development. There are current research areas that are found, which is black hole, neutron star, gravitational wave, and cosmology. Important discovery gravitational wave confirmed Einstein prediction over 100 years later. Linked to general relativity expands special relativity by including gravity. Limitation of special relativity. Special relativity is constrained by two major limitations. It applies exclusively to initial frame of reference and is failed to account for gravity. Furthermore, the theory presents significant conceptual hurdles as its principal quadratic everyday institution and demand highly limitation only valid of in initial frame does not describe gravity, difficult to understand intuitively. Why it's challenging, contracted everyday experience require abstract mathematical thinking. So the solution, as time later developed general relativity.
Now, to conclude our presentation today, we would like to summarize the overall things that we have discussed earlier. Now, relative theory changed our understanding of space and time, introduced time dilation and length contraction, connected mass and energy, as per stated in the Einstein equation, and lastly, revolutionized modern physics. Relativity teaches us that reality is more flexible than we initially thought, and extraordinary than human intuition suggests. Thank you for sticking to the end of the video. Thank you, and remember, reality is merely an illusion, albeit a very persistent one. Thank you once again, and have a very nice day.